There's this idea that creating something new means starting from nothing. A completely original thought, a blank page. But that's not entirely true. Every design, every invention is built on something that already existed. Ideas passed around, refined, reworked, sometimes even without knowing where they came from. It's less about coming up with something no one has seen before, and more about recognizing what matters, and putting those pieces together in a way that finally makes sense. That's where true innovation really comes from. Not because it came from nowhere, but because it came together in the right way. The idea was simple. I didn't want to build the fastest or most advanced bike. I just wanted something that was fun to ride, simple and playful. A bike you could take anywhere, anytime. Local trails, a pump track, jumps, or downhill riding. Something without weird gimmicks or unnecessary features. Just a good bike. At the time, that felt like a pretty straightforward goal. I started with the idea of a bike in my head. At this point, the challenge is in the design, not how I was going to make it. I started laying out suspension, and my design centered around the two main tubes having huge bends in them. I worked my way around the bike, modeling the front triangle, the suspension linkage, and the rear triangle. My first big video on YouTube showed a small 3D printed model of the frame with working suspension. I realized this was the way to share updates and get reality checks on my ideas. I would work on the design, make a video every week, and people would voice their ideas and opinions in the comments. Eventually my focus shifted away from the design itself and toward manufacturing methods. The bike lived in a constant cycle of design and reality checks. I tried out bent tubes, straight tubes with a plate steel lower shock mount, and the world of CAD catered to many wild ideas. Through this, I was losing sight of my original goal. I wanted to make a simple, fun bike, and these side projects were almost the opposite of that. I reopened the original file with the new goal of pushing through to the finish and making it for real. I still didn't have welding capabilities, so I worked on making a full-scale model out of PVC pipes. Made a jig for bending, and it took 3 tries to get it right. I notched them on the drill press and eventually used 3D printed plugs to glue it all together. This was my first bit of experience with making the bike in real life, and it ended in failure. After the glue supposedly set, the frame completely fell apart in my hands. It was time for another rethink. I'd seen bikes with this unique construction. Machined or 3D printed lugs are bonded or welded to basic round tubes. This allows for greater control over design features, potentially lighter weight and higher strength, but most importantly ease of manufacturing. By letting the computer do most of the hard work, all that's needed is straight cutting tubes and attaching them to the pre-made lugs. I talked with an Australian frame builder that uses 3D printed parts in his steel bikes. The first part to be replaced was the bottom bracket area housing the cranks, shock, lower pivot, and essentially holding the whole bike together. This opened up the opportunity to play with unique geometry and internal cable routing. I was intrigued by these 3D printed capabilities and replaced almost every joint on the bike. Steel was too heavy, so I decided to have the 3D printed parts be made from aluminum. This took out the possibility of welding, so I explored the idea of brazing the lugs to the tubes. I talked with a British frame builder about brazing and realized even that was beyond my capabilities. This bike has always been design driven, and the possibility of 3D printing encouraged design freedom with surface modeling and custom formed shapes. Bonding is often associated with 3D printing in the bike world, as a few bold frame builders have used it to their advantage. It allows for smoother stress transfer between joints, it removes the need for post-welding heat treating. More importantly, it would make my idea very possible. At this point, there was no need to keep the steel tubes, when basically the whole bike is aluminum. I switched the bike for the final time to a fully aluminum 3D printed and bonded construction. spent the summer refining the design, and I 3D printed full-scale lugs, bringing the bike the closest it's ever been to reality. I used aluminum tubes with 3D printed lugs to test construction. Now the goal was to refine the design while slowly replacing the plastic parts with metal until it's a fully rideable bike. The cool thing about a full-scale model is you can see everywhere where the design will work and everywhere where it falls short. A big thing I wanted to improve on over other bikes is noise. I wanted to make sure there was no cable rattle when going through rough terrain. 3D printing allowed me to make seamless internal cable guides, keeping everything quiet and hidden. I got a quote for the 3D printed parts to get a sense of pricing. Even though the design wasn't complete, the bike was still quite heavy, so in an effort to reduce the weight and cost, I removed the modular drop-out system. I made the 3D printed parts thinner, which reduces weight and manufacturing cost. Soccer season started and I continued to refine the design. I reached out to a few companies for components on the bike, and I found a machinist who made the linkage. In the meantime, I worked out the bent chainstay tubes and polished the internal cable guides. Just as soccer season ended, the machined linkage arrived and the bike was beginning to take shape. Seeing my design turn into a real aluminum piece was unlike anything I've ever seen. My videos started getting more views and the end was in sight. The project had gained a huge community and I didn't want to let them down. I couldn't wait to ride it. It was now winter time, which made chemical processes like bonding and painting really difficult. I 3D printed a jig to hold everything in place for the rear triangle and did my first bonding operation with the help of my dad. The next week I bonded the front triangle, which was much simpler. A big moment was being able to assemble the frame in one piece, put wheels on it and ride it around like a scooter. That proved it was possible and the frame was going to work. At this point, the frame was functionally complete. I could put all the parts on it and be done, however I wanted to keep going. One of the main reasons I went with 3D printing was the idea of hiding the seams and making an aluminum bike that looked almost like carbon fiber. Leaving it in raw would be cool, but I wanted to finish it as if it were no different from a bike that came from a big factory. I held a tournament-style vote on Instagram to decide the color. Midnight Purple came out on top, which is a special color Nissan did for their GTR in the 2000s. At the beginning, I thought this was something I had to figure out on my own. Just me trying to solve every problem as it came up. And every project prior, that's what it was. Trying things, getting stuck, starting over. But this time, it was different. What started as figuring things out alone slowly turned into conversations. Ideas being shared, questions being answered, people taking the time to help without expecting anything back. And somewhere along the way, the project stopped feeling like something I was just working on. It started feeling like something real. Looking back, none of this really came from me alone. Every part of it came from somewhere. Things I learned, things I was shown, things I understood because someone else had already figured them out. And maybe that's what making something really is. Not starting from nothing, but knowing what to take and what to leave behind. This is the story of how I built my dream bike. A journey that began with what I couldn't do, and slowly turned into something that only exists because of it.